So in this video, I will try to give a general introduction into the field of reinforcement learning. These are the topics that I will talk about. Reinforcement learning is an approach to machine learning that is inspired by behavioral psychology. Richard Sutton is considered one of the founding fathers of modern computational reinforcement learning. He gave several significant contributions to this field. Most common machine learning applications people use what we call supervised learning, and this means that you give an input to your neural network model, but you know the output that your model should produce, and therefore you can compute gradients using something like the backpropagation algorithm to train that network to produce your output. For example, if we want AI to play Mario game for us, if we try to do it with supervised learning, we screen capture game seasons from expert players, and then we could use the video frame from the game as input to a model. And the output could the directions that Mario could move. Given video frames in a new game, it would know how best to navigate to beat the level. But then we would need hundreds of hours of gameplay videos to train on. First of all, we aren't training our model on a static dataset, but the dynamic one. So rather than framing this problem as solvable by pattern recognition, we can frame it as solvable through a process of trial and error. This is a kind of problem that RL is made for. How can we formalize it as mathematically? We start off an environment where an AI or agent can perform number of actions in. Since environments are unpredictable, we want to keep track on its current state the agent acts in a given state of the environment. And based on its actions, it may or may not receive an award and increase its score. Sequence of states, actions, and rewards for the agent, the probability of each state depends on only immediately previous step and the performed action. This is called Markov property. Agent is making decision based on this property. This process is considered as Markov decision process. So if we want to do supervised learning, we have to create a data set to train on, which is not always a very easy thing to do. On the other hand, if you train your neural network model to simply imitate the actions of the human player, then by definition your agent can never be better at playing the game than human gamer. For example, if you want to train a neural network to be better at playing the game, the best human, then we can't use supervised learning. And reinforcement learning is a way to have an agent learn to play a game entirely by itself. Due to the increased interest of enterprises in reinforcement learning and its innovative capabilities, it has become the hottest job of the season and will continue to retain the job choice for professionals looking out for jobs in the tech industry. However, they would need to equip themselves with certain specific skills and knowledge to master the art effectively. These are the top 5. Neural networks are agents that learn to map state action pairs to rewards. Python is the major code language for machine learning and artificial intelligence. Dynamic programming is a method used for solving complex problems by breaking them down into subproblems, finding solutions for these subproblems, and then combining them again to solve the overall problem. Probability, because common sense is introduced into the deep learning system by applying probability theorems. Linear algebra is useful in machine learning in the sense that one can describe complex operations using the formalism notations and matrix factorizations from linear algebra. On which platforms can reinforcement learning run? These are the top 10 reinforcement learning platforms. So in this part, we will look at the OpenAI Gym, which is a toolkit for developing reinforcement learning algorithms. So let's start with opening the page, this page. OpenAI Gym has different kind of environments. Some of them are really complex environments and some of them just classic basic environments, and we will make an example with the card pool. First of all, we need to install the gym. So we will write pip install gym. That I already done it. Then we need to import gym. Now we need to save the name as a variable. So we will write environment name equals, it will be this name. Then we need to call gym.make passing in that name. So we will write environment gym.make environment name. So that now we can simulate a random playthrough. But first of all, we need to reset our environment stats by writing reset. And then iterate over a number of time steps. So for and each step we get a random action. So we need to and then we apply that action to the environment. And finally, we need to call render to display the graphics. So we will save and run. So now we can see the graphic of the card pool. So now you have a little idea of how to set up a basic interface for interacting with an environment on OpenAI Gym. Now I will continue to my slides. Now let's look at the few examples and applications of reinforcement learning in real world. RL is so well known these days because it is the mainstream algorithm used to solve different games and sometimes achieve superhuman performance. The most famous one must be AlphaGo and AlphaGo Zero. AlphaGo, trained with countless human games, already achieved superhuman performance. Yet the researchers later on thought back and tried a purer RL approach. Train it from scratch. The researchers let the new agent, AlphaGo Zero, play with itself and finally beat AlphaGo. In robotics, the ultimate goal of reinforcement learning is to endow robots with the ability to learn, improve, adapt, and reproduce tasks with dynamically changing constraints based on exploration and autonomous learning. Reinforcement learning is one of the most promising directions to actually get to very intelligent robotic behaviors. The other example is traffic light control. Researchers tried to design a traffic light controller to solve the congestion problem. Tested only on simulated environment, though their methods showed superior results than traditional methods and shed a light on the potential uses of multi-agent RL in designing traffic systems. To summarize, we can use reinforcement learning to optimize the agent for sparse, time-delayed labels called rewards in an environment. Markov decision processes are a mathematical framework for modeling decisions using states, actions, and rewards. The key distinguishing factor of reinforcement learning is how the agent is trained. Instead of inspecting the data provided, the model interacts with the environment, seeking ways to maximize the reward. In the case of deep reinforcement learning, a neural network is in charge of storing the experiences and thus improves the way the task is performed. Thank you for listening.